How's it going, guys? It's Matt. I'm going to teach you about electronegativity. What is it, you ask? Well, I define it as the power that an atom in a molecule has to attract electrons. As you can see here, it can be shown as a trend on the periodic table. As you go from left to right and down to up on the periodic table, electronegativity tends to increase. Now that you have an understanding of electronegativity, we can look at a chart displaying just that. The light blue represents the lowest electronegativities, and the red represents the highest. As you can see, fluorine has the highest electronegativity, and francium has the least. Okay, now for an example. If we have a molecule such as H2O, aka water, we can see that oxygen's electronegativity, which is 3.5, is higher than that of hydrogen, which is 2.1. This gives oxygen a negative charge and hydrogen a positive charge. All in all, if you compare the elements in a molecule's electronegativity, you'll be able to tell which side is the positive and which is negative. Now, some elements, such as carbon and oxygen, have closer electronegativities, making the oxygen slightly negative and carbon slightly positive. Lastly, for elements who have almost or identical electronegativity, share electrons equally. For instance, O2 is 2 oxygens, which will give you the same electronegativity for each oxygen molecule, resulting in an electronegativity difference of 0. So this electronegativity difference creates a nonpolar covalent bond. Electronegativity differences that are between 0.0 and 0.3 are nonpolar covalent, like O2. Electronegativity differences that are between 0.4 and 1.9 are polar and covalent. Now, any electronegativity differences that are between 2.0 and 3.3 are ionic. Now for some practice problems. Your first question is, what is the electronegativity difference between francium and fluorine? I'll give you some time to do the math. Okay, did you get 3.3? If you did, great job. If you didn't, keep trying. For our next problem, I'll be asking the charges of francium and fluorine. I'll give you some time to do the math. If you got francium being positive and fluorine being negative, congrats, you got it right. And if you didn't, keep working at it. You'll get it eventually. Okay, so lastly, what bond type does the francium and fluoride have? I'll give you some time. Did you get ionic? If you did, great job. If you didn't, keep working. Okay, that's all I got. Hope you enjoyed and hope you learned. Bye-bye.